يلا guys, just 1 minute and we start.
Okay.
All right, so let's start. Hello everyone, I hope you're doing good. Today's event is Raspberry Pi Python workshop. It's an online certified workshop that will introduce us to Raspberry Pi and how to program it. Today we have two speakers. The first is Sharbel Abidaher, currently an electrical engineering engineer. He is also the co-founder and current president of Rumia's Advanced Software Society, where he gives talks about theoretical and applied computer science. He has been with CoderMaker and IEA for 3 years now and has become a certified CoderMaker instructor, as he has taught people of all ages how to use the Raspberry Pi and Python to design and create awesome projects. The second speaker is Peter Fadol, a computer with from the EU, former vice president of the Robotics Club in the EU, and lead trainer for being a volunteer at IEA for more than 3 years, which gave him enough experience to train students in CoderMaker on topics related to innovation, making coding using the Raspberry Pi, Python in real-life solutions, as well as robotics, Internet of Things, and other applications, which made him a certified CoderMaker instructor. Guys, the floor is yours.
Hi guys, and welcome everyone to our Raspberry Pi workshop. As Hadi said, my name is Peter. I'm going to be presenting along my colleague Sharbil. Sharbil, if you'd like to say hello, just so everyone can know who you are. كل عم يسمعني صح؟
Yes, Sharbel, do you hear us?
Sharbil included.
شربل معنا بالميتنج بس يمكن ما عم يسمعنا.
No worries. إذا شي هلا I'll text him شوف شو الوضع. Anyways, as Hadi said, we've been working together. Okay, he has left the meeting. Anyways, he's gonna join again. بركي عنده connection errors. We've been working with IEA and CoderMaker. Hi, Sharil. In the field of robotics and IoT for quite some time now, and with their help, we gained a lot of knowledge, theoretical and applied experience to be working and teaching in this field in order to pass our knowledge to you guys. So today we'll be covering a small intro about the Raspberry Pi and Python, along with a few basic components and electronics, of course. So you guys get to know everything you need to accomplish a simple application using the material given in this presentation. And by the way, this presentation will be sent to Hadi at the end of the presentation, so it can be shared to you guys for future references. So without any delays, let's begin our presentation. For those who are not very familiar with the Raspberry Pi, as you can see, the Raspberry Pi is a fully functional computer that runs on Raspbian, which is an operating system just like Windows or OS on Mac. Okay, so other than the fact that it has almost the same functionality as a normal computer, it also has all the connections you need. For example, you have two 2.0 USB ports, an Ethernet port, aux jack, HDMI port, power input, and you have also ports to plug in the PiCam. You have a port for display if you have a display screen, and you have, of course, the SD card, which will be installed Raspbian اللي حكينا عنه هو operating system. But the most important feature about the Raspberry Pi are the Gpio pins. Gpio stands for General Purpose Input-Output pins that we're going to use later on. These are the most important features about the Raspberry Pi. The Raspberry Pi can be programmed using Python and many more other languages, but for now we will just cover Python. And of course, we will mention more details in our next slides. Okay, and here we have a small animation. Okay, we have a small animation that shows you the ports I just talked about, the USB ports, the Ethernet cable, the HDMI port, aux jack, and of course the power cable along with the SD card. Okay, next slide. So some of you may be a bit familiar with Python, but we're gonna give you a small intro about it just so we make sure everyone's on the same page. And along with a few concepts that will help you complete your assessments that will be given to you at the end of the presentation to be submitted in due time. Okay, so first of all, Python is a very easy, well-known programming language, probably one of the top 3 worldwide languages. And we're going to show you how to use Python to create applications on the Raspberry Pi. By the way, if someone has a Raspberry Pi with him at home, we took the liberty of adding a small tutorial on how to set up your Raspberry Pi to your computer, or else you could just project the Raspberry Pi to an HDMI cable along with a screen, a keyboard, and a mouse, of course. Okay, so here is the setup of the Raspberry Pi in case you have it at home. Okay, so everything you need to set up the Raspberry Pi to your computer is the SD card with a Raspbian installed on it, which is the operating system, an Ethernet cable, the computer, of course, a software called PuTTY, and a software called VNC Viewer. I'm going to share with you some links to install these softwares in the chat. Okay, so this is a link for PuTTY. I'm going to share it right now. And this is a link for VNC Viewer. Be shared as well. You can download the software from these links here. Okay, so first of all, okay, in order to get your Pi connected using PuTTY and VNC Viewer, you need to enable SSH. SSH stands for Secure Shell Connection. Okay, whenever you need to plug your Ethernet cable from the computer to the Raspberry Pi, you need to have SSH enabled. If it's not enabled, that it won't connect. Okay, connection will give you a failure message. As soon as you install PuTTY, you open it, you need to type here under hostname Raspberry Pi.local along with the port number 22. Okay, and make sure you selected on the radio buttons SSH, Secure Shell Connection. And when you're done, just click on open. It will open for you a prompt, okay, which you can see here. The prompt will ask you for a username and a password. The username is just Pi, P-I, and the password will be Raspberry, okay? It's in the slides here. If you go back one slide, you can see the default username and the default password for Raspberry. As soon as you input the username and the password, it will give you a certain message. Just ignore that. Just type after it VNC Viewer. It will give you an IP address here. Okay, as soon as you type VNC server, sorry, not viewer, VNC server, it will give you an IP address. You just copy this IP address, open VNC viewer and paste it and click on open. As soon as you click on open, it will open the desktop, the Raspbian desktop, so you can operate the Raspberry Pi however you want. I hope everything's clear. If it's not, there is a lot of documentation online. But we're just putting here the setup in case some of you have already bought the Raspberry Pi and want to try out some applications on it. So first of all, we're going to be covering some basic electronics. Before we start wiring and coding our electronics, we need to know what we're working with. So we took a sample of electronics which are most commonly used, and we based our examples on them. So we're going to start with LED lights. Okay. We're going to start with LEDs. I'm sure all of you have seen LED lights before in your house, cars, electronics, basically everywhere. And here's how they work. First of all, LED stands for light emitting diodes. They're very cheap. All they do is give a source of light. They have a positive side and a negative side. As you can see, one of the diodes is longer than the other. The long one is positive, the short one is negative. You can remember them just by the length. If not, it's really hard to see, but inside the light, there is a small difference inside. As you can see, the negative is cut this way diagonally. The positive has an extension up there, but you can tell from the length of the LED which one is positive, which one is negative. Now, the most important part is that the LED light takes up to 2 volts to turn on. Unfortunately, the Raspberry Pi dishes out a minimum of 3 volts to any electronic we plug into it. So if no one has figured it out yet, if we plug the LED light directly to the Raspberry Pi, it's gonna blow, because giving 3 volts to an electronic device that takes only 2 volts will explode. So that's why we use resistors. Okay, so resistors just protect our electronics from taking too much voltage. So we have to know which resistors to use, not to be too powerful resistors or just one, just to give enough voltage to the LED to turn on. We also have a very wide variety of electronics we use and components, just like the buzzer and push button. But unfortunately, we don't have enough time to go through all of them. So we're just gonna give few working examples of few components mentioned as we move on. And the first example is gonna be the LED light. And last but not least, we have the breadboard. I'm sure most of you have seen it in some of your courses, and whoever didn't encounter it yet, the breadboard is a tool we use to assemble all our connections together. So all the wires coming out of our electronics will be plugged in the breadboard, and which make our work much, much easier. And here's how the breadboard is connected. As you can see, we have a pattern up there, the ping pattern. All of these ping patterns are connected, but the pins above it and next to it are not connected. So whenever we plug anything on the ping pattern, it's gonna be connected to all of it. And on the other hand, as you can see on the bottom, there's the blue pattern. On the blue pattern, each column is connected to the other, but we must pay attention. The row below is not connected to the row up top. Okay, so I hope everyone understood how the breadboard works. If I'm going a bit fast, please tell me. إذا بدكم أحكي شوي
No, it's
عربي
very
شوي
good.
إنجليزي please قولوا لي like
As you like.
مثل ما أنتم بترتاحوا. I don't mind at all.
No, we prefer English as a sheet.
Okay, perfect. So, and here we have the Gpio Pins. Okay, in this presentation, we have the Raspberry Pi, and next to it, we enlarge the view of the Gpio Pins. هول البنز اللي عم تشوفون طالعين عمالة اليمين من الراسبيري باي هن أكتر بنز بنستعملهم فيها. هودي أهم بنز بتشوفون بالراسبيري باي لأن هودي اللي بخلونا نحكي مع الراسبيري باي. For example, we have 40 pins on this Raspberry Pi. There are other versions of the Raspberry Pi which have less or more pins. Here we have 40 pins, and each pin has a special functionality, and they are numbered from 1 to 40. The number 1 pin up top on the left is the first pin, and it gives out voltage. The voltage pins on the Raspberry Pi give out either 3 volts or 5 volts, depending on the electronic we want to use. So 1 gives out 3 volts. The number 2 pin gives out 5 volts. We're going to see now electronics that takes 3, takes 5, different voltage. And we have the GPIO pin. The GPIO pin, the general purpose input output, are the pins that let us control electronics. So everything we code, everything we write on the Python shell to the Raspberry Pi are going to be using these GPIO pins. And of course, we have the ground. Ground, obviously, is the negative part, okay? So we have the positive, negative on the LED. Obviously, the negative will go to the ground. And the positive will either go to the voltage or the GPIO, depending on how we need to use it. But remember, if we plug it into the voltage directly, it's gonna blow because it dishes out 3 voltage and not 2 as it should be. So next, we're gonna continue with Sherbel with the physical computing with Python. Sherbel.
Hi, everyone. Okay, so before we can start start wiring our components and actually doing the fun stuff, we must also do a quick review or introduction about the Python programming language. So Peter told you why we chose this language. I'm gonna explain a little bit and explain how it's written and go through the syntax with you. So if you have a Raspberry Pi at home and it's connected to a monitor through HDMI, or if you opened VNC connection to it, you can open IDLE, which is short for Integrated Development and Learning Environment. This is the default environment in which you can write and run Python code. And if you also downloaded Python through the link we sent in the email, you can also open IDLE on your PC. You don't need to be running it on a Pi at all. So to open it on a Pi, in case you have it, you go and click on the Raspberry Pi logo, go to the programming category and select Python 3. So what you'll see when you click that is the Python shell. It will be a blank screen like that with 3 greater than sign. So the Python shell is also known as REPL, short for read eval print loop. So every line of code that you enter here will be evaluated by the Python interpreter, and you'll see the results of it. Now, obviously, we don't want to write code line by line because it will be very clunky to go back and fix something, or if you want to run it more than once, we'll have to enter each line individually. So the shell is good for testing out some quick things, but we will not be writing in the shell. Instead, we'll be opening a new blank file with the extension .py. And we're going to write all of our code in this .py file. So you can go to File, New File, and then you'll be greeted with an empty file, such as this one, where you can write all your code, and then you either press Run manually, you go to Run and Run module, or you can press F5, or from the command line, you can run it using Python and the name of the file or the directory. Now, if you have Python, you can go ahead and write with us. Okay, so this, I'll go over the Python syntax really quick. I assume you have some familiarity with programming languages already, be it C or Java or C# or whatever else programming language you like. If you don't, you should be able to still understand, so stay with me. First off, variables. Variables can be thought of as boxes or places in the memory of your computer where you can save the data that you want to use, process, and transform in your program. This is the most essential part of any real program. So Python is dynamically typed, and it's not statically checked. So in Python, you don't need to specify the type of your variable. You just specify the name of the variable, and the interpreter will infer automatically what type of variable you've just entered. It also has many cool typing features, which I can talk about now, but it's very interesting. It's technically called duck typing, and so it can use variables in a lot of cool ways. Compared to Java and C++, Python has a lot more native variable types. So if you write C, you'll know that strings are not native variable types. And in other languages, you don't have complex numbers as native variable types. But in Python, you have integers, booleans, floating points, strings, and complex numbers. Those are the native variable types, which you can create like in the code we show here. You just need to write the name of the variable and then equal and then the value you want to assign to it. And as we said, the type will be inferred. One last cool thing for those who don't know Python, it has arbitrary precision, which means you can store theoretically infinite values of integers. It's not capped like in C++ or C. Now, let's get to the fun part. Okay, so suppose we have a light emitting diode, like Peter explained, and we want to just turn it on using the Raspberry Pi. So first thing to do is to look at the GPIO pins map that we went over just a few slides back, and then look at which pins are labeled GPIO. Those are the pins that we can control programmatically. The pins which are labeled as voltages we can't control, and ground, of course, we can control programmatically either. So here in this illustration, we chose GPIO pin number 10 to plug into the long leg of the LED, which, if you remember, the long leg of the LED should go to the positive part. Yeah, this is the chart again. So we chose pin number 10 and any random ground pin. All ground pins are connected to each other inside the Pi. So we wired the correct leg of the LED to GPIO pin number 10, and we put, is it found in Tinkercad? Yes, I believe so. And then we put a resistor to protect the LED from excessive voltage. We wired the other leg to the ground, and then we can get to writing code. So the most important part of any Python code when you're working on the Raspberry Pi is to import the library called rpi.gpio. So this library will contain all of the code needed to access and control the GPIO pins using Python. So you want to import the library rpi.gpio, as GPIO means that throughout the remainder of the code, when I say GPIO, I really mean rpi.gpio. So this is just a shorthand notation. Then we're gonna set the mode to GPIO.board. Also, like you saw in the map, in the pins map previously, you can either call the GPIOs by number or by serial code. We prefer to use numbers because it's just easier. So we're gonna tell the Python interpreter we're gonna use the board layout. So we're just gonna call each pin by its number. We set up the GPIO pin number 10 to be an output pin. This means that we wanna output voltage and current through this pin and not receive input. And then we can just set it to high. You can set the value of this GPIO pin to high to actually give current, and the LED will light up. Okay, we can also do something a little more interesting. We can make the LED blink. We can make it turn on for half a second and then turn off for half a second. To do this, we're going to use loops, which I assume some of you already may know, and we're going to use time.sleep. First off, I'll explain the parts of the code which we have not yet gone over so far. So let me now introduce you to control flow statements in Python. Peter, could you please switch? Yes. Okay. So first off, obviously, as you all know, we don't want code to just run from top to bottom. Sometimes you want to make decisions, and this is very true when we're coding in the Raspberry Pi. Say I'm coding a robot. I want this robot to make decisions when it can grab onto things, or where it can go, or where it can not go, or what should it do. So making decisions is really important in everyone's lives and also in code. So the easy way to know what decision you want to do is think about it in plain English, and you'll see how we're using it. So in Python, the syntax to take a decision is to use the keyword if. So you just write if, followed by a predicate which is just a comparison or a decision operator that you would like to do. So let's say if I want to compare two variables and say if this variable is less than this other variable, I want to light the red LED, and if this variable is equal to this other variable, then I would like to turn off a red LED, etc. So those are the Boolean operators which you can use, and you'll see how we use them here. So in this slide, you can see that we have a number which we're taking from a user. So the input function can allow us to take the input from a user. So in this short program that you can write yourselves now if you're fast enough, we're asking someone to enter their age. And then if this number is negative, we're gonna just tell them we don't believe them. So if number is less or equal to 0, we're gonna say that that's totally legit. So to tell Python that this line of code is inside the if statement, all I have to do is use a colon, which is not 10, go back to the line and then indent. So press tab or press spaces 4 times, though tabs are preferred. So if this number is less or equal to 0, we're gonna tell the user that they're bluffing, basically. Else, if it's less or equal to less than 18, we're gonna tell them that they're a kid. I'm sorry if there are anyone less than 18 years old among you. Then if the number is between 18 and 99, we're gonna just tell them the painful truth, existence is pain. And else, basically they're over 100 years old. That's, yeah, we can't tell them anything, just respect. Okay, next we're gonna talk about the loops which we have used to blink the LEDs. So first off, I'm gonna talk about the while loop. Oh yeah, so Peter wants to show you the code again. I hope you caught it. Okay, so loops are a way to repeat certain pieces of code. So let's say I wanted to blink an LED or on or off. I could just write like GPIO dot output pin number 10 high, then GPIO dot output pin number 10 low, then GPIO output pin number 10 high, and so on. But that's not really effective, is it? So we can use loops in Python to repeat our code many times, and they can also be used to lock a user inside a certain part of the code until they give a good answer. So if I was to write a login function, I could just keep the user in a loop until he enters the correct username or password, which we will see here. So the correct syntax would be the keyword while. So we're gonna say that while this condition is true, execute the following code. And this is what you do here. So while the key that the user has entered in this code, so the variable user key will take the password, and the variable system password is storing the real password. And let's say I wanted to just compare the password that the user has entered to the real password. So I would write in Python, while the key that the user entered is different than the system password, do the next 2 lines, which again are indented, which means I pressed tab beforehand. So tell the user that the access is denied and ask them to try again. And I will be stuck inside this loop, and I will keep running the same 2 lines of code until the user correctly enters the correct password, which is banana with a capital B. Then I will just print to the screen that he has access, or she. For loops are just like while loops. They are mathematically identical and they can serve the same function. The difference is that for loops are used to repeat a task a certain number of times. So if I know how many times I want to repeat a task, I would use a for loop. Just like the first example, the spaminator. Let's say I want to print hey 100 times and be that annoying clingy person. I would say that for I in range or for underscore in range 100, print hey. So what this code will do is that it will just print hey 100 times over on the screen. So the difference between this part of this type of loop, the for loop, and the previous type of loop, the while loop, which the difference is that a while loop, I wanted to keep running until a condition becomes false. I wanted to keep running while a condition is true. But in a for loop, I want to run a piece of code a set amount of time. Note that I can even make a better spaminator. So instead of saying hey 100 times, I can just say hey forever. And how would I do that? I would just say while true. So as we said, a while loop will keep executing the code inside of it while the condition that I wrote next to it is true. So if I tell Python while true, it will just keep running the code over and over again because true will always be true, if you understand what I mean. Okay, this is another example of a for loop. The variable that we're using in a for loop can be accessed in the code. I don't think we will need that right now, so you can just read it at your own convenience. Also, again, just to mention for clarity, that's another thing that we will not be using right now, but just for the sake of being correct, for loops are also used to pass over a list of items or any collection of items. So here in this example, we made a list of groceries, which have potatoes, tomatoes, radish, and human brains in them, just regular things anyone would go and get from the supermarket. And then I want to enumerate it and print it on the screen. So you can see the output on the right. If I do this, for item in my grocery list, print a dash and the item, then I would print the whole grocery list to get potatoes, tomatoes, radish, and human brains. So I hope now you understand the code for the blinking LED before. I hope we can go back to it, Peter. The blinking LED. Yes. So here we can check out the code real fast again. So as we said, we want to import the rpi.gpio library to use and control the Gpio pins. And we want to import the time library, and you'll see how it will be used. I set up the Gpio pin correctly. I set the mode and I set up the Gpio pin. And then I enter an infinite loop while true. So what will I repeat infinitely? I will set the Gpio pin number 10, which is the one I wired my LED to high. So which means I will turn the LED on and then sleep for 0.5 seconds. So basically I want to wait 0.5 seconds because I'll give it a little bit of time to show that it's actually turned on. Then I will turn it off again and then wait for another half a second. And I will just keep repeating those 4 lines, and so the LED will keep blinking forever. If Peter stays on the slide, it will keep blinking. So now, let's talk about traffic lights before we continue. So one of the assessment problems that we'll give you at the end is to do this traffic light configuration. So say you have 3 LEDs, a red one, a yellow one, and a green one. We want to turn on the green one for 8 seconds, and then the yellow one for 2 seconds, and then the red one for 10 seconds. You should know how to do it using a while loop and basing off of the code we've just shown. If you don't have a Raspberry Pi, you can just write the code for it and then wait till you get a Raspberry Pi so you can try it in real life. And then we have a very short Q&A. We'll have another Q&A session in the end of this presentation, but here's a Q&A now to get you
just to make sure that the pace is set to everyone's understanding where we're going. If someone's didn't understand the slide very well, we can go over the slide very quickly so we can move on with the next slides. So if anyone
if you have
wants
any
to
questions,
ask a
Hala, you
question.
can ask. That's the first Q&A session, then we have another Q&A at the end. If you have anything to say, just raise your hand and we will take your question, please. The pins are analog and digital. بيسأل Johnny.
No, well, the pins are digital, so you can only turn them on or off. You can simulate PWM. You can simulate power width modulation, but it's not exactly. It would not exactly be a power width modulation. So it's digital. It's on or off. But you can get accessories for the Raspberry Pi. You can get a certain hat that would allow you to transform your digital signal to analog. So you can do analog with a Pi, just not exactly directly. Can you build a traffic light on Tinkercad? Yeah, go ahead. I mean, we don't require it. You can just send us the code, but if you would like to. If you would like to do it and get some experience, then you're more than welcome. We might even
Ali has a
showcase your
question.
solution.
Excited.
Yes, yes. I was answering Nida. Ali. If we want to write them on the same line, what would I change in the code? Okay, so Peter, could you go to
Sure.
2 slides back?
Mm-hmm.
Okay, so in Python, the print function automatically inserts a new line character. Actually, Ali, can you tell me do you already know programming? So just to know how to answer you. Do you have programming experience or not? Yes, okay. So the print function in Python automatically inserts a new line character, \n. But you can tell it to not insert anything afterwards. So you would write something like this. I'm gonna write it in the chat. So you can have something like this. I'm fairly sure it runs. You can specify the end character so that the print statement would not insert a \n at the end. So when you run the next print statement, it will be just right there. You're welcome.
Okay, do we have any more questions,
I guess
or
we can
should
move
we move forward with the slides?
I can't see
It's okay.
is there someone
Yeah,
raising?
neither.
ما في حدا رفع ايده. So
Okay,
basically we
perfect.
can-
So,
ما تستحوا. Okay.
okay, so I need you guys to take a deep breath because we're gonna go into some more advanced components. And the components I'm talking about are infrared sensors, motion sensors, and ultrasonic sensor. Unfortunately, we're not gonna show you example of each sensor on its own, but we're gonna talk about the most used common sensor between them all, which is the ultrasonic sensor. But first, I'm gonna talk just like a briefing about the infrared sensor, which we can see here in the image. It's the first image on the left. The infrared sensor, it can detect light radiations from objects in its field of view. It has 3 pins, which is the VCC, which will be connected to the voltage, of course. The ground, which is going to be connected, which is the negative GND, it's going to be connected to the ground pin on the Raspberry Pi, and the output, which is going to be connected to the GPIO pin so we can program it however we want. And we have the motion sensor, which is approximately the same as the infrared. It has also the same pins. But here we have, on the last image to the right, the ultrasonic sensor, which has 4 pins. And it's going to be a bit complicated, so I'm going to need your full focus because its wiring is a bit complicated and the code is a bit complex if you want. I'm going to be explaining more of it on the next slides. And here we go. Okay. So the ultrasonic sensor's purpose is to measure distance using ultrasonic waves, as the name implies. The sensor has 4 pins, which is the VCC. And now I'm guessing you already know that it goes to the voltage. And this sensor takes 5 volts. As we saw on the GPIO pins and the voltage pins on the Raspberry Pi, there are pins that has 3 voltages and pins that have 5 voltages. So we're going to use the pin that takes 5 voltages. We're going to give it to the VCC of the ultrasonic sensor. We have the GND, which is the ground. We're going to connect it to the ground. And we have 2 pins, which are the trigger and the echo. Okay, so these pins are kind of interesting, and we're going to talk about them a little more. The trigger is like a trigger that sends an ultrasonic wave, and the echo is the thing that receives this wave to calculate the distance. The formula we use here is distance equals time times speed. And when we say distance, there's the distance that's going to go from the trigger and hits the obstacle in front of the ultrasonic sensor and comes back to the echo. So here we have Rawha, Raja. So we have 2 distances. This is why we type the formula 2D equals T times V, where D is the distance, T is the time, and V is the speed. Okay, and the speed of sonic waves are 34,300, but since we need to divide it by 2, since we have 2 distances, Rawha Raja, so it's going to be 17,150, and it won't change. Moving on, this is the wiring of the ultrasonic sensor. It's a bit complex, but if we focus on it, we can فينا نجزأها ونعرف كل component ليش وصلنا مع هالقد resistors. Okay, so as we know, the VCC will be directly connected to the voltage, which is 5 volts, in order for it to be functional. The ground will be connected to the ground, but there's a small twist. The trigger, which will send the trigger of the ultrasonic wave, will be connected directly to the GPIO pin. Okay, but the echo, when it receives the ultrasonic wave, it's going to be outputting 5 volts. If we connect the echo directly to the Raspberry Pi will take 5 volts. There's a small chance for it to burn or have a defect. So it's not safe to plug it in directly to the Raspberry Pi. This is why we use some resistors to protect this Pi from all this voltage. Instead of outputting 5 volts directly to the Pi, we plug in some resistors to take some of that voltage and make it approximately 3 volts instead of 5. Okay, so بدل ما نبعت له 5 volts على Raspberry Pi وتحتريه عم نبعت له 3 volts instead. Okay, so and the other resistors will be put to protect any voltages to be passed through the ground. انتوا كلكم تعرفوا اذا مرقنا voltage او حيلا شيء circuit مرق على الجراوند بيصير في اسمه short circuit. Short circuit is something very, very, very dangerous. Just like if you connect something positive to negative, short circuit, everything's gonna blow. Okay, so this is why we use resistors to protect our circuits. Okay, so here the dark line, the dark wire is the ground, supported by 2 resistors, so it can cut off any voltage from going to the ground. The green wire is the echo with 1 resistor, so it can dish out 3 voltage instead of 5. The yellow wire, which is the trigger, which is directly connected to the GPIO, and the VCC, which is directly connected to the 5 volts on the Raspberry Pi. I hope everything's clear about the wiring. In case it wasn't clear enough, there's this picture that can guide you And there is, of course, online documentation available whenever you need it. Now we're gonna move on to the code. Okay, you can see, and don't be afraid of the code. It's big, but it's so easy. We're gonna start on the top left. Of course, we need to import the library of the pins, the Raspberry Pi pins, the GPIO pins, and we need to import time. First of all, because we need to use time.sleep just like we did in the LEDs, and we need to calculate the time بالروحة بالمجية تبع التريجر. Okay, so first of all, we created a variable called trigger equal to 23. So we plugged the trigger to the GPIO 23 and the echo to the GPIO 24. And we're using the board mode, GPIO.setMode, GPIO.board. And we set up the trigger to be an output, and we set up the echo to be an input. Why? Because the trigger is outputting signals, and the echo is just receiving inputs. Okay, I hope this is clear for everyone. And now we're going to see a new concept in Python, which is the def. Basically, most of you know it as functions. So def is like definition, is the term we use to create functions. So here we created a function called ultrasonic_read. Okay, so basically to create any function you want in Python, you just have to write def space, the name you want to call your function in, parentheses, the parameters you want to give it, and then you close the parentheses, 2 point, you go on a new line, and we don't forget the indentation, which is the tab or either 4 spaces. Okay, then we said that the output, the trig_pin, will be set as high. High, yani it will be turned on. So if the trig is going to be turned on, yani I told the trigger to send a trigger, send a wave. Time.sleep, parenthesis 0.0001, it means that every 0.0001 second, I'm going to send a trigger, send a trigger, send a trigger. So I'm constantly sending triggers to detect if there's an obstacle ahead or not. And of course, every time I turn it on high, I should turn it back off. If it stays on high, I can't turn it on again. So after that, I'm going to do the while loop, just like Cheryl explained it before. I'm going to set the GPIO.input echo_pin, and I'm comparing it to 0. When we use double equal in Python, it means that I'm comparing. Whenever I use a simple one equal, it means I'm assigning a value to a variable. Just like we did here. When we said trigger equals 23, I assign 23 to the variable trigger. As we can see here in the while loop, when I said equal 0, I'm comparing 0 to the trigger. To the echo. What does it mean? Why am I comparing 0 to the echo? Previously, I've sent many triggers, infinite triggers. Keep sending triggers. But how do I know if this trigger has been received by the echo or not? If I'm comparing it to 0, it means I haven't received any. It is false. And I'm gonna and time.time is a function that gets me the current time, the time I've sent the trigger with. Let's say أنا بعت هلا trigger. Now it's 6:47. I'm sending triggers infinitely, and it's 6:47. In the next line, we see that the echo is going to be equal to 1. If that condition is true, then I'm going to get the time again. So now it's 6:48. I've sent it on 6:47, and I got a response on 6:48. I'm going to calculate the duration, which is going to be pulse_end minus pulse_start. Inside this variable, pulse_end, it's going to be 6:48 minus 6:47. Theoretically speaking, it's going to be 1 minute. So the duration is going to be 1 minute. How do we calculate the distance? If you remember the formula we said before, distance equals time times the speed of the ultrasonic wave. Distance equal, let's say it's 1 minute times 17,150. It's going to return the distance calculated. Let's say if I sent a trigger, it's going to hit an obstacle and come back to me. So it's going to give me the distance in centimeters of that obstacle, okay? Depending on the trigger, and the echo. And then to display the result, I'm gonna mention a while loop again. While true, whenever this condition is true, I'm gonna output the distance in centimeters every 1 second. Okay, so if someone is a bit confused, please raise their hand so I can re-explain. Because I know this is a hard concept. أول مرة بتشوفوا ultrasonic sensors. And the code is a bit complex, but I really hope you understood the concept of functions and everything you need to know about the trigger and the echo. So imagine like you're sending a pulse and receiving a
PC ما
pulse.
فهمتوه, just raise your hand. It's okay. So no one raise your hand.
So everything you need to know about the ultrasonic sensor is that you need to protect the circuitry with the resistors, because the echo dishes out 5 volts. It needs to dish out 3 volts, so we put 1 resistor. And لحتى مهود ال 3 volts ما يروح على الجراوند ويوصل فيه كهرباء على الجراوند, we're adding 2 more resistors so that الجراوند بيضلوا negative, ما عم بيصير عليه ولا circuitry ولا شيء, ما بيصير فيه short circuit. بالنسبة للcoding, it's very simple. The trigger is an output because it's always outputting triggers. Echo is an input because it's always receiving the sonic waves. And the formula here, distance equals time times the speed of the sonic waves. ونحن عم نحسب الوقت تبع السونيك ويف بالروحة وبالرجعة. أول ما أبعتها للسونيك ويف عم سيف الوقت عندي قد إيه هلا على السيستم. أول ما ترجع السونيك ويف عم سيف الوقت بالرجعة. So بعمل ساعة رجعت minus ساعة راحت, عم باخد الديوريشن تبعها, then I'm multiplying it by the speed تبع السونيك ويف وبترجع لي الديستنس. إذا حدا عنده ultrasonic sensor بالبيت at home or Raspberry Pi كمان, he can try on the circuitry and try on the code as it is. Return the distance he's gonna see, and whenever he puts an obstacle in front of the ultrasonic sensor, حتعطيه قديش distance من الobstacle للultrasonic sensor. Like whenever he removes his hand, بتروح قد ما بدها تروح. لازم تعرفوا إنه maximum range I guess it's 4 meters and the minimum is 3 centimeters تبع ultrasonic sensor. And interesting fact, if you put an obstacle diagonally in front of the ultrasonic sensor, it's gonna diverge. It's not gonna come back unless it's parallel to it. Okay, so that's all you need to know basically about the ultrasonic sensors. And then we're gonna move on with the DC motors.
Before that, Peter, you have a question in the chat.
Yes, how you keep sending pulses in this code? Okay. Okay, as you can see here in the code. Okay, عندك line gpio.output trig pin, comma gpio.high. That's the first line after the function. Okay, after the definition. Okay, when I say gpio.high, it means I am telling the trigger true, يعني go. I'm turning the trigger on. Whenever I'm turning it on, عم بقول له بعت trigger وانطر ليستقل echo. Okay, so every 0.00001 second, I'm sending triggers. So I'm sending infinite triggers all the time. Whenever I turn it off, it's gonna stop. So basically speaking, I'm turning it on every 0.001 second, and then I'm turning it off very fast. So it's going on and off, on and off, on and off, on and off, sending infinite triggers, and then I'm waiting for our case to be true, which is the echo. So whenever the echo is true, يعني it got the trigger back, so it's gonna calculate the duration and give me the distance. It's gonna return the distance. Okay, I hope it's clear. Okay, perfect, Ali. If someone else has any questions toward the ultrasonic, please ask it now, because after that, Sharbil is gonna go through DC motors and the driver. Yes, of course. Time.time is a function that will give you the current time on the system, on the computer. Yeah. But in seconds, of course. It's going to give you the time in seconds. Pulse_start is like, it's storing the time I send the trigger. Okay, let's say I sent the trigger at 6:53. Okay, and I received the trigger back to the echo on 6:54. The duration will be 1 minute, aka 60 seconds. So since أنا استعملت pulse start و pulse end، يعني أنا حسبت الوقت اللي راح فيها والوقت اللي رجع فيها. So بعمل الوقت اللي رجع فيها minus الوقت اللي راح فيها، حيعطيني إنه it took 1 minute. Since it took 1 minute حيقول لي إنه هال 60 seconds اللي عم تعملها I'm gonna multiply it by 17,150, which is the speed of the ultrasonic wave, and I'm gonna give you back the distance. Okay, I hope this is clear to you too, Saad. Okay, perfect. Okay. Okay, in the second loop, okay, if I don't put time.sleep, we're not gonna see the results. It's gonna put infinite results. But إذا بحط time.sleep 1, every 1 second, it's gonna display the distance. إذا بحط time.sleep 5, it's gonna display the distance every 5 seconds. Okay, so أنا حطيتها ثابت، حطيتها 1 second time.sleep 1، يعني in each second حتعطيني display للديستنس in 1 second. من بعد ثانية راح تقول لي الديستنس، بعد ثانيتين بتقول لي الديستنس. Okay, perfect. Okay. Any more questions, or we can move on to the next slide? I guess not. Okay, would it be too fast? Oh, أنت. Yes. Okay, so Sherbil, I'm gonna give you the spotlight and
Yes.
take it on from here.
Okay, so if you have any more questions, we'll have another Q&A, and I'm just gonna tell you that usually the ultrasonic sensors and the DC motor are two parts with which people struggle a lot to understand. So don't feel discouraged to ask, because everyone struggles with them. And if you did understand them properly, then you can feel happy about yourself. So a DC motor, it's a device that will convert electrical energy into mechanical energy. You give it a current, and it will turn, and it will drive whatever's on the other end of it. I'm sure most of you have seen electrical motors, be it DC or AC. Now with the Pi, we can just run the DC motor directly. So a DC motor has two input pins, as you can see in this picture on the back of it. So you can see the shaft that will turn in the front, and you can see at the back the two input pins. So the difference in the voltage between these two pins is gonna drive the DC motor, and it's gonna determine what direction and speed it will turn. So the greater the potential difference or the voltage difference, the faster it will run. And if I inverse the polarity, it will turn in the other direction. So there are no diodes inside this motor to force me to choose one pin to be positive and the other pin to be ground. And we will exploit this in the code, as you'll see. So Peter already told you many times already, no, keep it up. Peter already told you many times already that the Pi does have a 5-volt pin, but the issue is that this 5-volt pin cannot sustain 5 volts with a high enough current to really drive a DC motor. So you could just plug a DC motor directly to the Pi, but it would not be really efficient. You better use an outside battery pack and a certain chip that we'll talk about to be efficient in driving the DC motor. So the IC chip that we use is called L295 3D. So it's made, it's also called an H-bridge, if I'm not mistaken. It's made to control the voltage of the motors, and the D stands for diodes. So it has many diodes, and we'll see the map of this IC. So I assume you've seen what an integrated circuit looks like. Some of you, it's this black thing. It's a small black thing that has pins like a spider. So this is the map of the specific integrated circuit that we like to use with a DC motor. You could use another one, but this one is fitting for the purpose. So it has 16 pins that we numbered from 1 to 16, and basically the pins from 1 to 8 are symmetrical to the pins 9 to 16. This integrated circuit can actually run 2 DC motors at once, one wired to the left of it and one wired to the right of it. We're gonna go one by one. So we have 2 enable pins at pin number 1 and number 9. If this enable pin is set to high or it's set to 1, the motor will run. So it's like a switch. It's an on-off switch. I'll give you a better analogy in a second. But if it's set to 0, then regardless if the other pins have voltage, the motor will stop. So a better analogy would be imagine a power plug into the wall and your TV. So even if your TV is turned on, or you give the command to your TV to turn on, if the power plug is not plugged in the wall, it will not run. Similarly, if this enable pin is not set to 1, even if the other command pins are set to high, the motor will not run. The other pins N1 and N2, and mirrored on the other side N3 and N4, these will tell the motor in what direction to turn in. Then 0V is the ground, obviously. So you have 4 ground pins, and they are all internally connected. So you can just connect to one of those if you would like. Plus V motor is the power input. So as we said before, we need an external source of power for the DC motor. So this chip allows us to disconnect the power and the control. The power will come from the battery pack that we'll show you in a bit, and it goes to the plus V motor. And the control that comes from the GPIOs of the Raspberry Pi will come to the N1 and N2 pins. So that's how we will drive the motor. We'll disconnect the power from the control, because if you remember beforehand, the control and the power for the LED light and the ultrasonic were the same. So I used to turn on the LED light just by setting a certain GPIO pin to high, and this GPIO pin would power the LED. Here I'm gonna power the DC motor externally. Finally, out 1 and out 2 will connect to the motor to drive them. So if we go to slide 43, we'll see how it will all interplay together. Could you go to slide 43? Yes. So we have a Raspberry Pi, which will give the controls or the orders. Plus V motor is used for both motors. Yeah, I believe so. I believe so. If I'm mistaken, correct me, Peter.
لا صح.
Yes, okay. Then we'll have this IC chip, which is the motor driver that can control up to 2 motors, and the battery pack, which will power these 2 motors. Okay. Slide 45, if you could, please. Okay, so here's a little chart to understand how this how this integrated circuit works. So as we said before, if yes, Peter.
Malchi.
So as we said before, if the enable 1 is 0, no matter what the other two pins, N1 and N2 are, the motor will just not run. It will turn off. It will not run. So this is kind of like unplugging a device from the wall. Now, we take the case where the enable pin is set to high. Okay, so this, we have plugged our device, our electronic device in the wall, but maybe we haven't given it the command to run yet. So if the enable pin is set to 1 and the two pins N1 and N2 are set to 0, then the motor will not run either because it's plugged in. It's the enable of decoder and logic circuits, yes. Yes, it's just like the enable in logic circuits. This is inside of this chip is a very basic logic circuit, I believe. It should be XOR. It should be just XOR inside of it with extra diodes, and you can deduce that, I think, from the logic from this logic table, right? If anyone is good at logic and it's not XOR, you can correct me. I believe so. So if N1 and N2 are both off, then the motor will not run. If N1 is high and N2 is low, then the motor will turn clockwise. If N1 is off and N2 is high, then the motor will turn counterclockwise. And if both are on, then it will be in an undecidable state, so it will just be off by default. But it's better to not rely on this behavior. So don't rely that if I give both pins, yes, it is XOR gate. So don't rely that if I give a high output to both pins, it will not run. So it's this is the behavior.
So
yes, so
yeah.
This behavior would happen, but as a programmer, you should not get into this gray area. Okay, is it clear before I move on? Okay, I'll assume it is.
Yeah, it's clear.
Okay. Clear. Okay. Thank you, sir.
The wiring is a bit complex, so حاطين بس الوايرنج تبع one motor. مش حاطين الوايرنج تبع two.
So 1 and 1 should be 0. Yeah, the motor is turned off. That's what I mean by 0.
The enable is turned off, so ما في power واصلة على على drivers, so it can work.
So go up, Peter. So you can imagine that N1 and N2 are the two input variables, and then the last column on the right is the function or the output variable, the result. It's not exactly XOR because it's not like 1, 0 just gives it 1. There's also the polarity. So you can see if N1 is 1 and N2 is 0, then it turns clockwise. And then if N1 is 0 and N2 is 1, it will turn counterclockwise. So in a binary XOR gate, this would mean just the motor running, but here the motor is running clockwise or counterclockwise. So it's a trinary system, if you will, but it's close enough to a XOR gate.
Johnny is asking which is faster, the Raspberry Pi or the Arduino response. It depends on the use, صراحة.
It depends on the use. Well, yeah.
The Arduino is faster in basic operations, but the Raspberry Pi has much more features. So Raspberry Pi is like the brain that controls an Arduino. The Arduino is just a muscle that moves.
So the Arduino is a microcontroller, but the Raspberry Pi is a microcomputer. So they have different purposes. If you're looking for just pure response time, then the Arduino would be faster, and also you program it in C, so it would be blazing fast. But
Yeah.
on the downside, it doesn't have any processing power. It doesn't have any onboard memory. It doesn't have uh, any real output. So that's the definition of a microcontroller. You just use it to control other circuit elements like servos, DC motors, whatever it
So
is.
basically, they're not comparable. You can't compare the Raspberry Pi with the
Yes.
Arduino. If you want to compare two microcontrollers, you can compare the Arduino and the SP8266. It's a much smaller version of the Arduino, and it has higher capabilities. If you want, you can research it. It's a very useful microcontroller.
Yeah, the SP it's awesome. It's great.
Yeah.
And a Raspberry Pi is a microcomputer. So some people use Raspberry Pi for servers. Actually, some people host websites on a Raspberry Pi. It has an actual CPU. It has a 1.2 gigahertz CPU. That's the 3B model, if I'm not mistaken, or 1.5 gigahertz CPU.
Yeah.
And it has half a gig of RAM, also for the 3B model. For the 4 model, you have many gigabytes of RAM. Raspberry Pi 4 has up to maybe 4 gigabytes of RAM with a much more powerful CPU. So it's like a tiny computer compared to a microcontroller. And like Peter said, you can wire the Arduino to a Raspberry Pi, and that's what they do in real robotics. I think I was disconnected.
No, Badak, you're still here.
Okay, that's what they do in real robotics project. They have one Raspberry Pi to be the head or the main, and then many Arduinos connected to it to be like an extension, like the muscles, like Peter said.
Slaves, yes.
Slaves.
You can have the master slave. The master is the Raspberry Pi, and the slaves are the Arduino. So the Raspberry Pi gives all the commands to the Arduino. The Raspberry Pi gives the commands to the Arduino in order for it to do everything, operates electronics, components, etc., etc.
Is it clear? Could you reply to us?
And the new Raspberry Pi has a Bluetooth device, so it can communicate with the Arduino using Bluetooth.
Correct. It can connect to a monitor by itself and a mouse and a keyboard and yes, okay, clear. So I'll continue with the DC motor. Can I move forward?
I guess so, yes.
Okay, so the wiring of the DC motor can look a little complicated in this picture, but it's exactly what I've been telling you about. So basically, you need to have 3 GPIO pins going to the integrated circuit. One for the enable, one for the N1, one for the N2, and then the positive part of the battery pack will be wired to the plus V, to both plus V, or just one, it's all right. Then the negative part of the battery pack will be wired to the ground, and it will also be wired to the ground of the Raspberry Pi so that we can work at the same ground. All electronics will be working at the same ground. And then out 1 and out 2 will go directly to the DC. It doesn't matter which one goes to where, just like we said. And then we can control the DC motor with the following code.
By the way, you should know إنه ما بعرف if you mentioned it أو لا, بس the ground and each side are connected to each other يعني.
Yes.
5 are connected, and 12 and 13 are connected.
Yes, I mentioned that.
Okay, sorry.
And this is the same in the Raspberry Pi. So when you connect the two grounds to each other, the Pi, then we'll have a code which is generally good to do with the electronics. Can we go to the code?
already فتح الكود بس I guess في lag شوية.
Yeah,
or
okay, I
internet
can see
connection
it.
issues. Okay, good.
I can see it, yeah. I have internet issues as well. Okay, so here to drive the DC motor, we chose to wrote functions in the code because it's better, as we said. So if we want to send many commands in the same code, we're just not gonna repeat the same lines of code. It's bad practice, as you know. So we created 3 functions which we called forward, backwards, and stop. So let's take a look at them. Also, of course, we set up all the pins correctly beforehand and assigned the numbers of the pins to the proper variables. What will the forward function do? Let's reason about it a little bit. So we want the DC motor to be running first off. So we're gonna set the enable to high, and let's say that the counterclockwise direction is what we are gonna call forward. So then we need to set the N1 and N2 pin appropriately. So the N1 pin will be set to low, and the N2 pin will be set to high, and the enable pin will also be set to high. So we chose counterclockwise direction to be forward, but it doesn't really matter. You could just switch the connections of the DC motor, and you'd have the opposite logic. We can also see a function called backwards, which will also set the enable pin to high at the end, but it will first set the enable 1. Actually, this should be, fix that. It should set the N1 to high and N2 to low, if we were to call it in the same way. And then the stop function will just set the enable pin to low, because as we said before, it's enough to set the enable pin to low, or to turn off the enable pin. The motor will just stop running. We don't really need to bother with the N1 and N2. Yeah, I fixed it backwards. Now I see your chat. So here's how we will. Here's this test code. So first, we're calling the function forward. We're gonna let our car or DC motor go forward. We're gonna pass the arguments to the function. By the way, this is how we pass arguments to functions. By the way, when in the definition of the function, we say how many arguments we want to take. So in the function called forward, we are taking 3 arguments: en, n1, and n2. And when we're calling the function, we're passing the enable of the motor 1e and the n1 and n2 of the motor 1. And I'll show you why we did that in a few minutes. So what will our code do? It will go forward for 2 seconds, and then it will go backwards for 2 seconds, and then it will stop. And this GPIO.cleanup is necessary to just flush all the GPIO pins and reset them to the normal values, which should be low. So this is in case we turn the enable pin off, but the N1 or N2 was still on. So here's a little bit of Python code or Python tricks. So if we want our code to be reusable, and we already said that our IC chip, the Ultrasonic 3D, can control 2 motors, then it's a good practice to write the function forward, backward, and stop such that they take the enable pins and the N1 and N2 pins as arguments. So then if we had 2 motors, we could here write, for example, forward and then motor 2E to pass the enable of the motor 2 and then motor 2A and motor 2B. So if we had two motors, we could use the same function that we defined to drive both motors. We wouldn't have to rewrite the function again. So this is a little explanation of why we wrote it the way we did. And I believe that's all I have for you today about the DC motor. We're gonna talk a little bit more about the assessment, which is just little practice rounds or just a little questions we would like you to little questions we would like you to answer to determine.
Yes.
Yes, Peter.
أنا كان عندي connection issues هلا ما سمعت إذا قلت لي شيء ولا لا.
No, I didn't. I think I disconnected as well.
Okay.
So we're gonna tell you about some of the assessment questions that we put to just
Yes.
make sure that you are following with us and to get your certificate.
Yes, since we've been informed that certificates are mistakes and you're gonna earn some certificates of, okay, we have a question.
Let's wait the Q&A session. It's better.
Okay. Yeah, we'll wait for the Q&A and we're gonna answer all the questions. إذا بدكم ما تنسوا الأسئلة تبعكم اكتبوهم على الشات ونرد عليكم بعدين. In the meantime, since حنعطيكم certificate of a simple application, you will actually have to do a simple application. So we gave you 3 questions and you can choose 2 of the following questions. اللي حبيتوه أكتر شيء الكومبوننت الأكتر شيء حبيتوه فيكم تستعملوه تعملوا application عليه. So I'm gonna explain each assessment لحاله. The first question is to write the code for the traffic lights at slide 35 using variables and loops. We're gonna go to slide 35. This is it right here. So we have 3 LEDs. قطعته مع شربل عليها. We have to turn on the green light for 8 seconds, the yellow light for 2 seconds, and the red light for 10 seconds. إذا بدكم reference عن الكود لأن أكيد ما حتحفظوا syntax وحتحفظوا code right away. فيكم تاخذوا reference من ال blinking LED أو من ال LED دايما مضوية. Okay, so reference your answer بحسب هيدا الكود. So the difference between the assessment and this code is just that you need to add 2 more LEDs and you need to figure out كيف بدنا نخلي كل LED ضوي simultaneously. مثلا the green for 8 seconds, the yellow for I guess 2 and the red for 5 seconds. Yes, I guess that's it. Yes.
The red for 10.
I guess so. 35, it's here. Okay. Yes, مظبوط. Red for 10. Thank you for the correction. So this is the first assessment that you have. If you have more questions about this question, please قالوا هلا. إذا لا, we're gonna move on to the next question.
So I think no one has a question.
Okay, we can always go back to a question إذا ما فهمتوا كثير منيح. And the second question we have, it's like a fun question.
Excuse me, Peter.
Yes.
Someone's asking a question about the first.
No, you don't have to link it to any pin. You just have to write the code. Okay, بكل الاسسمنتس you just have to write the code لأنه بعتقد مش كلكم عندكم راسبيري بايز، مش كلكم عندكم LEDs، مش كلكم عندكم wires. So we understand that ما حنجبركم تستعملوا pins أو electronics. You can just write the code and it's enough for us. The wiring already نحن عطيناكم إياه بالpresentation, so you don't have to do anything extra. Yes, we're gonna send the presentation to Hadi and Hadi is gonna forward it to you by email. مظبوط Hadi? Okay, so that's a nod. That's yes. Okay. If you want, you can do it in Tinkercad. We don't mind. Blackest will be more than happy. We're gonna send you an email. على هيدا الإيميل بعته هلا على الشات. راح تبعتوا لنا كل الاسسمنت
Yes
تبعكم
guys
ونحن
بعد
we're gonna
بعتكم كل
correct
شيء
them.
ما تستعجلوا.
No worries, ما بأثر. I understand the enthusiasm. وحنبعتكم correction إذا كان في need correction. And إذا كمان كان بدكم تعرفوا more info or more explanation, we're more than happy to help. إذا ما بقى في questions about the first assessment, I'm gonna move on to the next. شربل إذا سأل سؤال please let me know لأنه أنا حكون عم طلع slides. Thank you.
ما سمعتك شو
Okay, so إذا حدا سأل سؤال please stop me لأنه أنا عم فاتح عند السلايدز. I can't see إذا حدا عم بيسأل أسئلة.
Yes, sure.
Okay, so in the next assessment, this is year 2025, and we are headed to the moon. You are required to use if statements and the ultrasonic sensor to warn the astronaut about incoming meteors at any distance below 10 meters. So نحن مثل ما شفنا قبل example ultrasonic sensor. كمان same thing, you don't have to use the wiring already محطوط قدامكم. You just have to alter the code using if statements تقولوا له للأسترونوت اللي طالع على القمر إنه انتبه في ميتير جاي عليك in 10 meters. يعني ماشي بدكم بس تحطوا له warning. You should print out a warning إنه في ميتير جاي هلا بعيد عنك 10 meters. Okay, so الكود كمان موجود بالسلايدز. You just have to use the if statements in a way to give him a warning sign إنه watch out, there's a meteor coming. Okay, come in, same thing. If you have any questions, ask it. How much time you have? Yes, correct. Till Sunday. Submissions on Sunday. إذا خلصون قبل الوقت كمان you can present them. بس كل شيء correction بيصير on Sunday. ما حنصلح شيء قبل الوقت. بس طبعا حدا يبعت أجوبة للتانيين. بدنا نكون fair مع الكل قد ما فينا. And the third
Yeah,
question.
sure. Guys, anything related to the workshop راح نبعث لكم إياه. No worries.
Yes.
Okay.
Everything will be sent to Hadi, and Hadi will send everything to you by email. Third assessment we have is to modify the DC motor in slide 47, which is right here, in a way that every time the car is going backwards, a white light should go on, and every time the car moves forward, only a green light should turn on. Okay, نحن بتتذكروا أخذنا الليدز بالأول فسرنا كل شيء عن الليدز. So same thing, هون we have the DC motor, we have to alter the code إنه كل ما تمشي الويل أو الموتور لقدام بده يضوي a green, I guess, green LED. Yes, a green light. Whenever the wheel or motor is going backwards, a white light should be turned on. Okay, هلا you're not required to write the code for two motors, only one مثل ما مكتوب هون. ما حنقلكم تزيدوا بعد motor. You just have to add إنه whenever the motor is going forward, a certain LED will go on. Whenever it's going backward, a certain LED will go on. وأكيد بدنا نرجع نطفي الليدز. ما المفروض يضووا اثنيناتهم ذات الوقت. و of course ما تنسوا تحطوا البينز. اوكي كيف نحن عاملين هون variables مع البين نمبر تبعهم. كمان بليز حطوا رقم البينز لانه don't forget انه they should be connected to certain GPIOs. ما بيصير نحط connection على الجراوند او على الفولتج مثلا والا بنكون كتبنا كود على الفاضي. So you guys are required to choose two of the following assessments. نقوا اللي بدكم اياها. واذا حدا حابب في يعملون ثلاثتهم بالعكس we don't mind. بعتوا لنا الانسرز على الايميل يلي you can write it on notepad or you can write it on the idle يلي هو البايثون كود اديتور. بس ما بيأثر فيك تكتبوا على نوتباد تكتبوا وين ما بدك we don't mind. او حتى you can copy paste it on the email. بس اكيد قلنا اي assessment نقيت من بيناتهم. the email صار معكم هلا بالشات واكيد هادي رح يرجع لكم اياه again and again. now حنفتح مجال لل Q&A. So if someone has any questions regarding
Please guys, if you have any
presentation,
question, just raise
our
your hand.
assessments, go ahead. It's open to everyone.
Sure. Please بس لنشوف كم حدا في عنده أسئلة. Just raise your hand to manage. حسن غسان تفضل.
جود ايفنينج.
هاي
هلا
حسن.
هاي اول شيء يعطيكم العافيه شباب، بس انا عندي سؤال ما خصه ريجاردينج الماتيريالز اللي اخذناها. يعني ان
Yes, go
جنرال
ahead.
على الراسبيري انا صراحه ما كنت بعرف شيء، يعني فكرت شيء تاني غير اللي اجيت شفته هون. يمكن كان لازم يكون عندنا باك جراوند عن اللي اخذناه اليوم ولا لا؟ ما خاص.
هلا Raspberry Pi isn't something very easy و very it's actually something very broad. يعني Raspberry Pi كتير واسعة، وإذا بتفوت فيها عن جد بتفوت ببواب إنه كتير كبيرة وكتير صعبة توصل لكل شيء بالراسبيري باي. سو نحن قد ما فينا جربنا نصغر الكونتنت تبعنا تنلحق نعطيكم إياها بساعتين. سو أعطيناكم a couple of components مع الكودز تبعهم والوايرنج، بس بالراسبيري باي فيك تعمل اشياء اكثر بكثير من هيك واشياء very different.
يعني انا بعدني لحد هلا ما عرفت البيربس اوف يوزنج راسبيري بايز، وانا هول استصعبتهم اللي عم تعملون البنز وهالقصص. يعني ما عندي ايديا قبل. وفي شغله ثانيه يمكن يعني اي ريكومند يو اذا لو فيكم تعملوا مثل لاب مثلا، مش سلايدز، لانه بحس السلايد واضحين. انا حضرت شوي فيديو على يوتيوب، يمكن اخذت لقط من هونيك اكثر من لقط من هون، وانا ما عندي فكره ابدا عن الراسبيري ابدا.
Usually Raspberry Pi workshops بيكونوا hands-on workshops. يعني we actually give Raspberry Pis to all the students وهن بيجربوا يعملوا الوايرنج بإيدهم وهيك. بس لأنه it's an online workshop جربنا قد ما فينا نعملها interactive مع الانيميشنز وهيك. وسنس كان معنا كمان time constraint ما كان فينا نعطيكم وقت لتجربوا كل شيء عندكم بالبيت كمان. بس إنه of course إذا كان عندنا opportunity نعطيكم hands-on workshop we don't mind حسب هذه كمان. بس انه for 2 hours
Unfortunately
that's
شو
the
بدنا
best we
نعمل
can do.
كرمال
اكيد يعني ساعتين يعني
كمان
ما بلحق الواحد
lockdown
يعمل.
weekend يعني.
بس
صح
عندي
صح،
بس
لا معك حق معك حق حسن صح.
one more question بس. اذا واحد بده يشتريها بلبنان how much it cost يعني؟
راسبيري باي بعتقد في 2 providers بلبنان either IEA او في سوري في عندك كذا provider. في أترنجة، في IEA، وفي نسيت شو اسمه كمان. بس تقريبا برايس تبعها between 30 في الكترو لابس كمان between 30 and $50 حسب الاكويبمنت شو بدك تجيب معها LEDs sensors motors.
اوكي thank you so
بس you can
much.
find it in any online electronic store وهيك.
بعرف أترنجي.
علي زعيتر
صح صح.
اوكي thank you so much.
ولو
Let me answer Ali's question about the IC. Well, أول شيء you saw how this IC is used. So any different motor that can be driven like this, you can use هيدا IC معه. بس then you have some extra limitations. So let's say you have a DC motor with diodes in it, such that ما فيك تقلب أي pin عم تعطيه positive voltage و أي pin عم تعطيه ground. Then this using this IC معه would be a little dangerous because you risk sending the wrong polarity and burn it. For example, if you have other types of DC motors that need more than just 2 inputs, then maybe you would need other ICs. And lastly, if you have a bigger DC motor, if you have like a really big DC motor that needs a really high voltage, then I doubt that this L293D could sustain a very high voltage or very high current. So you would have to look at the rating of the specific IC that you bought, and you would need to check if the voltage is all right. And yes, like a servo motor. The servo motor can be driven with the Raspberry Pi using PWM. We couldn't cover it right now, but yeah, for example, a servo motor would need a different type of IC. Another question. You can use LT-Spice, you can use Replit, you can use Tinkercad, you can use Proteus, you can use Eagle, you can use any software you would like to use to simulate the circuits, these circuits, and you can use any coding environment to write the Python code, be it Idle or Python or Replit. You're free to use whatever is comfortable to you. If you have a Pi, you're free to try on the circuits yourself. In the time.sleep, you mean time.sleep function,
Yes,
the
it's in
input
seconds.
is in seconds.
Yes. علي حدا جاوب عن servo motor يما لا؟
I did answer, but if you would like to add something more.
No. إذا you answered, it's good.
Okay, so well, غير عن servo motors, the Raspberry Pi can be used to power a very, very wide array of electronics. You can use servo motors, gyroscopes, infrared sensors, motion sensors, different types of lighting. You can power, like you said, other Arduinos. So there's really no limit to what you can wire to a Raspberry Pi and what you can do with it. This workshop was just to get your feet wet and get to know the process of creating electronics with a Raspberry Pi. And those components that you know are enough to get started and do like a slightly big project that could involve many parts which we've shown you interacting with each other. So let's say an ultrasonic sensor and a DC motor. So you could make a car that doesn't hit obstacles, for example. You already have a wide array of things you can do, and any other part which you would like to add to the Raspberry Pi would function تقريبا in the same way. So it either has input or output, and you've learned here today how to handle both input and output. And if it has different protocols, then it's more complicated. You can handle it on your own.
Sure thing. Thank you. Questions, guys? If you have a question, please raise your hand, just to know. جاد تفضل.
منصور، أنا كان بدي أسأل في ناس مش خاصة بالأسسمنت، خاصة بالسؤال عن الدي سي موتورز. في ناس تعمل، إذا بدنا نستعمل دي سي موتورز لنعمل قفل، يعني بيبرم مرة شمال مرة يمين، هل فينا نستعمل هيدا واحد تاني؟
في كذا type of motors. إذا بدك كل موتور عنده تورك معينة، يعني في موتورز عندهم تورك أقوى من غيرهم. في موتور معين اسمه الستابر موتور. ستابر موتور هو موتور أنت ما فيك تبرمه، يعني إذا هو برم to the right أنت ما فيك ترجع تغير له الاتجاه تبعه، أو you need like a really strong force. So إذا بدك فينا نبعث لك documentation عن الستابر موتور و you can use it in your project إذا أنت عم project أو شيء. It's much more efficient than the servo or the DC motor. ومع إنه تستعمل servo for this purpose كمان.
إذا فيكم تبعتوا لي هذا كنت أعمل.
Yes, of course. هلا بنزيدهم على البرزنتيشن نبعتهم لهادي، هيك الكل بياخذهم كمان.
ميرسي.
Sure thing.
And thank you guys for the feedbacks.
تفضلوا, feel free please. أليسا تفضلي.
Hi, I have a question عن إذا أنا عم بستعمل الراسبيري باي. So I've tried it a few times, 3 years ago, 2 years ago. أول عزناها we connected it through the Ethernet cable, بس I don't remember من بعد فتي وإذا استعملنا ال VNC، لأنه I remember إنه كنا نحن عم نستعمل الراسبيري باي عم نشوف السكرين تبع الراسبيري باي على our laptops. هلا year ago استعملت باي جديدة ما قدرت أعمل هذا الشيء. استعملت يعني I used a monitor, a mouse, a keyboard, etc. So بالطريقة يلي فرجيتونا إياها نحن بالأول which way will I be using my pi؟ لأنه أنا عندي الباي اللي إجت يعني من شي 1 year أو 2 years.
No worries. هو في two ways to use the Pi. Either you plug it مثل ما عملتي على يعني بتعملي projection على screen و you plug a keyboard and the mouse أو you use it using an Ethernet cable using SSH connection. بس you should make sure إنه قبل ما توصليه على Ethernet cable وتنزلي PuTTY و VNC يكون في رح فرجيك هلا بالبرزنتيشن تكوني عاملة enable لل SSH. إذا مش عاملة enable لو وصلتيه وعملتي كل شيء مزبوط it's not gonna open. انت لما تفوتي على الراسبيري باي على ديسكتوب لما تعملي بروجكشن وتشكي ماوس وكيبورد تكبسي على لوجو الباي بتفوتي على configuration. اوكي بالconfiguration بتروحي على انترفيس بتلاقي كل شيء فيتشرز بالراسبيري باي اذا هن enabled او disabled. سو اجباري تعملي enable على SSH لانه في كثير اوقات لما تنزلي عليها كل شيء راسبيري وهيك بتجي باي ديفولت ال SSH disabled او حتى بيكون حاططها disabled بالغلط. سو make sure it's enabled. وإذا بدك تعملي كونكشن على اللابتوب أو حاجة لأذر كمبيوتر نزلي بوتي VNC viewer بعت اللينكس أنا بالشات تبعهم إذا بدك تعملي لهم
Yes,
داونلود.
yes, I saw them. هن بعدهم عندي بس لأنه I didn't know إنه فيها تكون هي disabled ال SSH already فيها على
Yes,
الواي.
it's a possibility. إذا ما زبطت it's a possibility تكون disabled.
Okay.
وعملي الكونكشن المفروض تمشي smoothly يعني ما مفروض تعملي ولا مشاكل.
Deal. Thank you.
ولا دنيا.
Thank you, Elisa. Guys, تفضلوا. Anyone has a question? Seems everything's clear. Wow. Welcome, Nora. Welcome. So, if you don't have any question, I'm just gonna say thank you so much, Sherbil and Peter. Thank you so much, guys, for attending today's workshop. إن شاء الله تكونوا استفدتوا. Again, like the guys said, the following is their email, so you can send the project, and if you have any other questions, you can send them there. Of course, you must do the project to have the certificate. So once you do the project, you'll have the certificate hopefully by next week. Don't forget to follow us on social media, IEEE LIU Student Branch. We're available on Instagram, Facebook, LinkedIn, YouTube, and we have a WhatsApp group. And this session will be uploaded on YouTube at the end of the event, so you can invite your friends to check it out. Also, we'll share all the needed links in the description of the video. So the presentation, the slides, the link for the software, everything will be shared on in the description of the YouTube video. I'm gonna send now my number and the number of the Vice Chair Omar Banat. If you have anything, any other thing, so these are our numbers. Again, thank you guys, and have a nice day. Thank you.
Thank you.
Have a nice evening.
Thank you,
actually.
everyone. I hope you enjoyed.
Thank you.
Yep.
Thank you.
Goodbye.
Bye bye guys.
Bye bye.